Right, let's work this out. Let's see how you guys did. So I've got a triangle that's isosceles triangle, JKL. We're going to put this on a coordinate plane. And its base is JL, is A units long, and K, the vertex, is on the y-axis. The height is B units. Okay, so K is on the y-axis, so that's going to be up here. That's K. And JL is the base, so that's going to be down here. JL. Here's my, am I high enough here? There we go. And so there is my isosceles triangle. KJ and KL are the sides that are congruent. And the base is B units long. From here to here is B units. And B is A units. K is B units from the origin. Okay, so now let's label these points. So K is 0, because that's we're on the x-axis, so 0, B, high. Now L and J, I might be a little bit tricky here, but I think we can do it. We know that the y value at both of these is 0. Y is 0. Now if JL is A units long, then I have to decide how far is it from the y-axis to L. It's half of A, right? So half of A is A over 2, or 1/2 times A. And then on the other side, it's going to be negative A over 2. Ta-da! All right, so that's what your U-try should look like right there. Now, I've got some other U-tries to give you. Let's go like this. A couple more U-tries. So for this one, I am going to have you draw an isosceles triangle. Isosceles triangle XYZ, where X is at the origin. X is at the origin. XZ is the base. And it is A units long. And that is all I have for you. Oh, Y is, the isosceles triangle, let's do it this way. Isosceles triangle is B units tall. There we go. That's all the information you need. Okay, so put this isosceles triangle on a coordinate plane and label it. Go ahead and pause and get to work on that. All right, let's see how you did. Coordinate plane, X is at the origin, XZ is the base that is A units long. So the base, so remember when you have an isosceles triangle, the base is this part here that's not congruent to the other legs. So the base is A units long. So from X to Z, there is A units. Now you could have put XZ and put the Z back here. That'd be fine. It would still be A units long. Some of your points might look a little bit different than the points that I'm going to give you. They will just be negative. The X values would be negative if you put the Z over here. The Y values would still be positive. All right, and then I've got my vertex up here, which is y, and it is b units tall. This isosceles triangle is b units tall. So now I need to label these points. X is 0, 0. Z is a, 0. That's the x value there is a. So if it was over here, it'd be negative a, 0. Now up here, this y, the y value is easy. That one's b, right? Because it's b units tall. But now I've got to figure out what is my x value here. And this vertex is halfway between x and z, because these are congruent, so that means this distance is exactly halfway. So if I know the whole way is a, then halfway is 1/2 of a, or a over 2. If you did z over here, then it would be negative a over 2. Okay. Let's I think that's good for those U tries here. Let's go on with 4-8. The one thing that I would like to do here is remind you of the distance formula, and that is the rest of what we're going to do here. Formula for 4-8. So 4-8, remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this was in 4-7, but I think that this is the time to remind you of it in 4-8 here. So here's an example. We use this to prove a rigid transformation, really. So we use this, so maybe it is better to, I should have put it on 4-7, but it's okay. We use this to prove a rigid transformation. Oh yes, okay. So here's our example. I have a coordinate plane. I have a triangle here. And I have a triangle here. And this is A, B, C. And this is A prime, B prime, and C prime. A is 2, 8. B is 6, 7. C is 4, 2. C prime is 4, negative 2. B prime is 6, negative 7. And A prime is 2, negative 8. And so the way we use the distance formula to prove that this is a rigid transformation is that we can see this is a reflection here. And what we need to do is prove that this distance, if we were to cut it in half, it would be that this distance, and this distance, they all have a relationship with one another. But we also know that, and so we could use that to help us with the distance formula, using the distance formula to prove a rigid transformation. It'll be a little bit easier to do that if you were proving a translation where it just gets moved. But since this is a reflection, it might be best to prove that this side is congruent to this side, and so we use the distance formula, and we can prove that this side is congruent to this side, or is the same length, and this side is the same length to this side. So that's how we can use the distance formula to prove that these has been a rigid transformation. So we're just going to look at one of these. We're going to say, does AB equal A prime B prime? And so in order to prove this, we would do this with every single side. We would say, is AC equal to A prime C prime? Oops. And we would say, is BC equal to B prime C prime? Let's just look at one. And just for time, we don't need a huge long video. If these are equal, if all three of these equations are true, then you do have a rigid transformation. If they're not, then you don't. One side is too short, or too long, whatever. Okay, so AB is the square root of, so A, if this is x1, y1, and B is x2, y2, 6 minus 2 squared plus 7 minus 8 squared. And A prime, I'm just going to set up A prime, B prime here before I get to work on this one. So A prime, B prime, so A is x1, y1, and B is x2, y2. So x2 is 6 minus 2, 6 minus 2 squared, plus negative 7 minus negative 8. Negative 7 minus negative 8 squared. All right, let's do this. 6 minus 2 is 4. 4 squared is 16. Plus 7 minus 8 is negative 1. Negative 1 times negative 1 is positive 1. So I've got the square root of 17. AB equals the square root of 17. Just leave it as a radical because we're just going to check if we're just checking to see if they're the same. So there's no need to plug it into a calculator. 6 minus 2 is 4. 4 squared is 16. Plus negative 7 plus 8 is going to give me a positive 1. Positive 1 squared is 1. So I get the square root of 17. So yes, AB is the same distance as A prime, B prime. Now I need to do that for AC and AC, A prime, C prime, and I've got to do that for BC and B prime, C prime. And so that's how you would go about solving or proving that this was a rigid transformation. And that is all we're going to look at for 4-8 and this little review of something I should have said in 4-7. All right.